Hello everyone, and welcome to lesson number 9 of my deep learning course. In this lesson, I will teach you how to create your first multi-layer perceptron, all from scratch. So, without further ado, let's get started. Whether you want to implement AI into your business or you just need consultancy from a machine learning expert, I'm the right person for you. From acquiring data till deployment, my multiple years experience will provide you full support which will help you to boost your business. To find out more, check the link in the video description. Welcome back everyone. So this video is the part 2 of solving your first deep learning task. And in this Jupyter notebook, I will teach you how to build your first multi-layer perceptron from scratch for our binary classification task. If you have missed lesson 8, I recommend you to go and watch that video first and then come and continue with this video. If this is the first video that you guys are watching from my series, I recommend to start from lesson 1, where I explain how to set up the Jetson Nano for deep learning and how to program it from the web interface like we're doing here, and then continue the series from that point. As always, you will find the link to where to download this Jupyter notebook in the video description. As always, here you will find the video for this lesson. Don't forget to like, subscribe, and activate the notification bell. So, what changes from a single neuron to a multi-neurons neural network? During lesson 2, we saw that a neuron is just a linear function, y is equal mx plus b. So how does it work when x is not a single value anymore, as we saw in lesson 2, but is a vector instead? Well, the weight m this time is not a single value, but it also becomes a vector, one for each individual input. For the bias instead, that is only one bias per neuron, which means if we have 10 neurons in our layer, we're going to have a vector of 10 biases. If we have only one neuron, then it's going to be a vector of only one element with one bias. So to make stuff a little bit simpler with an example, let's say that we have an input x and it is a vector containing 3 values, 1.0, 2.0, and 3.0. Now the weight m, as I mentioned, is also a vector. So let's assume with values 1.0, 1.0, and 1.0 to make stuff simple. Finally, the bias is again one single value since we have only one neuron in this case. So in this case, let's say that the bias is 0. Now we need to multiply each input with the corresponding weight. In this case, the result will be a vector of 1.0, 2.0, and 3.0 because is basically the same since we multiply by 1 everything. But now we know that a neuron can output only one single value and cannot output an entire vector. So now what do? We sum every element in the vector. So we will have 1.0 plus 2.0 plus 3.0 is equal to 6. And this operation is called dot product. If this is not clear to you, you can watch a tutorial from Khan Academy, and I left a handy link here in the Jupyter notebook. After this dot product, now we can finally add the bias. So since the bias was 0, the output of the dot product is 6.0, so the result is again 6.0. Now let's write the formula that describes this process in a more generic way. The output is equal to bias plus the sum from element I till n of x of I times w of I, where b is the bias, of course, x is the input vector to the neuron, w is the weight vector of the neuron, n is the number of inputs from the incoming layer, and I is the counter from 0 to n. So now this is how a single neuron computes its output. This process has to be repeated now for each neuron in the same layer. So instead then of vector, we will have matrices, but the concept is the same. So now let's go into coding. As always, we need to make sure that we are running this Jupyter notebook with TensorFlow 2 virtual environment. If you guys get any error, as always, you can go up here and switch the kernel to TF2. Now, let's implement all this function into our multi-layer neural network from scratch. So, this is the class. I already created a class for you guys. As a few changes respect to lesson 7 and can be summarized as follows. Now, the number of layers is not defined into the constructor, but we have a function to add layer. Then the weights now have different shapes depending on number of inputs and neurons per layer and are randomly initialized. This is very important, so we don't initialize with 2.0 like we were doing before. The constructor now accepts the parameter input shape, which defines the shape of the input, self-explanatory. Now we use the dot product as explained before instead of a simple multiplication for the output. For ReLU, leaky ReLU, and parametric ReLU, TF maximum and TF minimum now compute the operation on vectors instead of values, since we need to deal with vectors at this point. This time, since we are doing binary classification, we must apply sigmoid on the final layer. Because if you remember, sigmoid outputs between 0 and 1. So this is going to be our probability to belong to class 1 or 0. So we must have this sigmoid function at the end of our network. Last, the train function now accepts a generator, so not the old data x and y like before, but a generator, since we will train one batch at a time. So we need to have a generator which feeds the network instead of throwing all the data at once and calculating everything. If you miss how we got to this point, check my previous lesson, and as I mentioned, I recommend to start from lesson 1 so that all those concepts are going to be a little bit more clear. Now, I will not go into detail and explain line by line how I did this. You can check anyway, you can download this Jupyter notebook and see it by yourself. Of course, if something is unclear, you can comment down below and ask me some question on how I did something. And of course, I'm going to reply to you. But if I start to explain line by line what happened here, it is going to be a little bit too long. I can briefly summarize anyway. So anyway, we can execute this code to initialize the class. We can see that now from the call function, for example, we apply the sigmoid activation right at the end. Then we use the matmul, which basically is the dot product in TensorFlow instead of a single multiplication. For the p-ReLU, we can see that now instead of a simple value, we have a matrix of zeros with the same shape of the input. Same for the other functions. Probably the most important function here is the function add layer, which I specify only the number of neurons that we want in the layer in which we will add. And then here, the weights and the biases at this time are going to be, as I mentioned, have some matrices with some shapes. And I initialized the biases with 0, of course, and the weights with the Glorot uniform. I implemented here from scratch, and I don't want to go in details to explain how this works, because there's going to be a specific lesson in the future on how to choose what kind of initialization for our weights we need according to what kind of activation function we use, what kind of data, and so on. So now let's go into the loss, and the loss remains the same as always, at least for now, so mean absolute error. And before you say it is wrong, I know that cross entropy is better when we talk about classification, but this is going to also work. Mean absolute error can also be used for classification tasks. So since here didn't change anything, I don't explain any further. We just execute the function. And now it is finally time to create our neural network. It's still very simple to create now. So I just specify the batch size. For the input shape, remember that either we give the same batch size as we define, or we can also pass none, so that it can accept any value. So we initialize our neural network class and we choose as activation ReLU. So by automatic default is going to apply ReLU after each layer. And then after initialization, we call 3 times neural network.addLayer, and then we specify how many neurons we want in that layer. So a layer 5 neurons 2 times, and then of course for the output layer is only 1 neuron since it's a binary classification. Then we compile the network, specifying the loss and the learning rate. So we execute the code here. Now, in order to test our neural network, I created a dummy data generator. It's basically looped forever, and it just throws some, always the same data, so always once. But I wanted to make sure that everything works as expected. So now to train the neural network is very straightforward. We call nn.train, we pass the data generator, number of steps, and how often we want to print the loss function and all the information. And as you can see, everything works as expected. So we have a print statement every 5 steps with the loss at each step. So in the next lesson, we will train our neural network with the data created during lesson 8, and we will see how to improve the performance for this task in different ways. So that's it for this video. If you guys like my content, you can support me on Patreon, where you can speak directly with me, and also I can give you advice on how to get started into this career. Another way to support this channel is to use my affiliate link that I give you in the video description for your purchases at no cost for you. Finally, another way to support me is to subscribe and share this video on social media. So I thank you for now, and I hope to see you in my next video.